kind of want to have day one. Sanjay is going to really do a full introduction for us. But what we really wanted to do is to give those of us in the room, the social scientists, who understand a lot about the social part, but maybe understand a little bit less about those dementia variables you have in health and retirement study or WLS, or in the range of different amazing population-based studies funded by the NIA at this point. We really wanted to give folks a real sense of like what those variables really mean in practice. So we're delighted to have you all, looking forward to the day, and I will pass it on today.
You put one up. Yeah.
I'll just do a really quick extra thing on behalf of Dave, but also the Wisconsin Longitudinal Studies. Dave, Pam, and I have been really fortunate to work on for years now, which is that we have learned a lot through this interdisciplinary collaboration between this sort of long-term social science and the Center for Clinical Excellence in Alzheimer's Disease Research at ADRC. We've been implementing some of these implementing the things that we've learned by bringing sort of clinical rigor into a population-based science and sort of population-based and representatives into studies of Alzheimer's. We're really excited to share this with you and also to build on tomorrow's session where you will hear about many other studies that are similarly integrating these biomedical and social science perspectives. So we hope this will be a fruitful event for all of you, and thank you for joining us.
Sanjay, we're going to say something. Hey, welcome. Glad you're here. And thanks. I want to just acknowledge all of the support staff that have helped us get us here. We have the project coordinator, EdDem, and Alicia is the one that helps with ADRC, and then Naomi helps. I don't know. Okay, and Kate. Sorry for that. So thank you all for all of your help getting everybody here and wrangle. After one page we were packed, but there you go. So
We've got Amelia Carter here from NIA video.
Good morning, everybody. It is our pleasure to be here. Please come and say.
Thank you so much. Well, thank you so much, and good morning, everyone. My name is Sanjay, and what I'm going to do is to start the presentation by introducing you all to the Alzheimer's program and give you a little feel of the program here, the depth and the scope of research that goes on here. If I get disconnected here. Hey, and then we'll talk about multiple programs that are active within the Alzheimer's Center, the ADRC, and many scientists share what goes on in terms of research here. So, all right, this one. Thank you. All right. So, big question: why do we need to study Alzheimer's? Well, there are multiple reasons, but in my opinion, I think the most important reason is that there are patients that Alzheimer's causes, or the patients that can be. And the society at large. It is a multifaceted, complex disease. Get a feel about that as the patient go on. So currently, over 7 million Americans. These projections are that unless we find some more effective treatments and prevention strategies, there'll be about 14 million Americans by 2060. The lifetime risk for Alzheimer's disease at the age of 45 is about 20% for women and 10% for men. Alzheimer's is the 6th leading cause of death in the United States currently, and 5th over the age of 65. And unfortunately, the mortality from these has steadily increased in the last few years. Just in the last 5 years, gone up by 140%. Last year, we spent over $380 billion to care for people with this disease in the United States alone. And in Wisconsin, there are about 130,000 people with the disease. The last year we spent over $900 million Medicaid dollars just in Wisconsin alone to care for the disease. So the socioeconomic impact of the disease alone is very substantial. Brief history. This is Dr. Alzheimer's disease and the woman there in the picture is the first known case of Alzheimer's disease that Dr. Alzheimer's diagnosed when she reported for him in a mental asylum in Frankfurt in 1901. So at that time, Augusta Lee was 51-year-old. She went to Dr. Alzheimer's. She was admitted to the asylum, and Dr. Alzheimer's was the attending physician at that asylum in Frankfurt. And her symptoms were memory problem, word finding problem. She got more confused in the evening. And then over time, about 5 years after this very short period of 5 years, she really progressed very rapidly and died at an age of 56. Dr. Alzheimer's, being a researcher, he was a psychiatrist. He actually performed an autopsy on her brain. And he described changes which are now the diagnostic hallmarks for Alzheimer's disease. So we will show you those changes. But let me share with you what is dementia. There's a WHO definition. People confused about dementia and Alzheimer's. Are they connected? Different. So dementia is an umbrella diagnosis and a disease that causes memory, psychiatric, and behavioral symptoms. And these symptoms interfere with the daily living activities that is important. And Alzheimer's is the most common cause of dementia. And by the way, dementia is not a part of healthy aging. It is a disease, so that keep that in mind. There are multiple diseases that cause dementia. Alzheimer's is the most common cause of dementia, accounting for about 65 to 70% of patients. The other common causes are Lewy body, Parkinson's disease, a combination of Alzheimer's vascular changes in the brain. And when that happens, that is known as mixed dementia, because they have Alzheimer's as well as multiple vascular evidence. And then there can be a combination of Alzheimer's and Lewy body as well. So look at the bottom here, this statement, hopefully you all can read. What this is saying that majority, and keep this in mind because we'll talk about this throughout the day, majority of people whom we diagnose have Alzheimer's disease clinically, over 80% of those people will have co-occurring diseases in the brain that also account for their memory symptoms. And these diseases include Lewy body, Parkinson's disease. They include a protein called TDP-43, which causes ALS, alpha-synuclein, which causes Lewy body and Parkinson's disease. So in addition to the abnormal proteins of Alzheimer's, majority of patients will have these other co-occurring pathologies for which we have no diagnostic test. We don't have a biomarker, anything blood-based. So this is an exciting area of research, biomarkers of co-occurring pathologies. And this program is the first that we would like to launch that program. And we are really starting to identify blood and imaging biomarkers of those other abnormal proteins, especially TDP-43 and alpha-synuclein. So these are the two diagnostic hallmarks that Dr. Alzheimer's described. So on your left is the amyloid plaque. See that in the center is the toxic form of amyloid, one of the proteins that gets positive in people with Alzheimer's. This is what a beta amyloid. And this is surrounded by dying neurons, neurites, a lot of inflammation in the brain and oxidative damage. So over here, the amyloid plaque will cause death of brain cells. Important to note that when someone has first symptom of the disease, amyloid and the tau, I'll talk about that, start to get deposited 15 to 20 years before someone has any symptom. So that pre-symptomatic phase of Alzheimer's is long and is pivotal, but that's the phase we cannot diagnose through PET imaging of amyloid. And hopefully we can intervene with some new medications so that the person never develops any symptoms, right? They have the proteins, but they have no symptoms. So we can do treatment and prevention strategies, and also perhaps one day we can stop the progression of the disease. This is a tangle. Tangle is present within the neuron. This is present in the brain tissue. Tangles are made up of these tau proteins. Amyloid and tau are the two proteins that are caused. Okay? And then over time, they all result in death of neurons. All right? I'm sorry. Okay, there you go. Under simple microscope, there are amyloid plaques and neurofibrillary tangles look like, and these are the PET scan. This is an amyloid PET scan, and you see the red areas and the yellow area, this is all amyloid that is deposited in frontal lobe, parietal lobe, and the midbrain area. And here the tau protein is deposited again in the frontal, parietal, and the midbrain area. So now we can image these proteins, and that is a real breakthrough in neuroscience research. That's showing some scans of a person. Here's someone with Alzheimer's disease. He's a normal person. This is an MRI brain scan. The look in the normal person, you cannot see that, right? This is the hippocampus. You can see this right here. Now compare this to this. See that how atrophied that shrunken hippocampus is here compared to a normal person. So one of the early signs of Alzheimer's disease or MRI is atrophy of the hippocampus. And this is the amyloid deposition in front of the parietal and the midbrain part of the brain. And this is, this is tau and then amyloid. And in a normal person, you don't see any of these proteins. Another thing I think I mentioned early, this slide just projects the fact that there is a long pre-symptomatic phase of Alzheimer's disease, around 15 to 20 years, and that is where all the research here in the field is focused on, the preclinical phase of Alzheimer's. How can we diagnose it? How can we treat it? And so on and so forth. All right, so clinically, Alzheimer's presents in two major forms. One of them is the familial form. This is caused by dominant genes. So someone has inherited it from their family, okay? And this is an aggressive form of the disease. Most of the people with familial Alzheimer's don't account for 5% of patients with Alzheimer's, but they will have symptoms in their early 50s, and many of them, unfortunately, die before they reach late 50 or early 60. So it's an aggressive form, but very rare. And this is the most common form of Alzheimer's. 95% of patients have sporadic Alzheimer's disease. If their sporadic Alzheimer's starts below the age of 65, they're known as young onset sporadic Alzheimer's disease. And if it starts after 65, we call it the late onset. The gene which is linked with the sporadic Alzheimer's disease is the ApoE4 gene. Raise your hands up if you have heard of this. Oh, okay, all right. And this, of course, increases the risk of Alzheimer's by if someone is heterozygous, one copy, about 3 to 4-fold, and 2 copies is about 8 to 12-fold. Alzheimer's pathology affects specific parts of the brain. Even in the most advanced stage, it does not affect whole of the brain or the brainstem. And based on the part of the brain involved, you can predict what symptoms will be. So the frontal lobe, their symptoms are mainly psychiatric, behavioral, social disinhibition. Those who have temporal lobe involvement, language is the major problem. Word finding problem, they have dysphagia, they can't express themselves, they don't understand what you're talking about. Hippocampus, of course, the memory is the dominant symptom right here. And then the parietal lobe. So the frontal, temporal, parietal, and the hippocampus. These are the parts of the brain that are commonly involved by Alzheimer's pathology. And when the parietal lobe is involved, it mediates visuospatial aspects. So what that means is it gives you a 3-depth perception. And people with that part of the brain involved have problems driving, they fall, and so on and so forth. So the symptom of the disease really is determined by which part of the brain is affected. Now, in 2024, Lancet Commission, they published risk factors and they divided them according to early stage, midlife, and late stage. Early stage education, you've got a lot of experts here, how education either increases the risk of Alzheimer's disease. You'll get a chance to talk with them about this important risk factor. In midlife, you will see that the majority of the risk factors are vascular diseases, and they are all treatable. High blood pressure, diabetes, high lipoprotein, hearing loss, physical inactivity, excessive alcohol, obesity, smoking, depression. You see, all these diseases are treatable. And when you do that, of course, you reduce the prevalence of the disease. And in late life, it is social isolation. That's something added in the 2024 report compared to the earlier report of 2019. Social isolation, social connectedness, and then visual loss and ear pollution. So the message here is that over 45% of cases of dementia can be prevented if you address these risk factors. All right, and this slide just depicts the interaction between the social and the biomedical side. And that social biological basis of Alzheimer's disease and related dementia is critical for us to really understand how these factors interact, and these interact with genetic people is more important and result in dementia. A rather simplistic representation of the social biological aspect of Alzheimer's. So that was a little intro to Alzheimer's because I wanted to kind of form a background. Let me now describe the Alzheimer's program here at University of Madison. It is a very large program. There are two pillars. One is the Wisconsin Alzheimer's Disease Research Center, which is an NIH-funded center. And the other pillar is the Wisconsin Alzheimer's Institute that Dr. Carlson leads. This institute supports a world-renowned study called the RAP study, Wisconsin Registry for Alzheimer's Prevention, and the ADRC. So between the two studies, there are large cohorts. I'll talk about them momentarily. That have been followed for up to 22 years. And in addition, there's another study which Dr. Johnson leads, and this is the largest grant ever awarded by NIH to University of Madison. And this study focuses on biomarkers of those co-occurring pathologies I mentioned to you earlier, TDP-43, alpha-synuclein, and so on. By the way, this grant is $150 million grant, one grant, and it involves all ADRCs in the country. So this is the Wisconsin ADRC, is one of the 35 NIH-funded centers of excellence in dementia research. Thanks to Dr. Paraker and NIH for supporting it. The ADRC here has been funded since 2009. It's been funded continuously for 17 years. And it is fortunately very renowned and one of the largest programs in the country in Alzheimer's research. Its scientific theme from inception has been preclinical biomarkers of Alzheimer's disease and how these biomarkers can predict transition from pre-symptomatic to symptomatic phases of the disease. It involves more than 40 investigators that are spread across the campus, and it supports research across the full spectrum of Alzheimer's, from molecules to patients, to communities, to dissemination implementation. Huge structure of the ADRC. It has 10 different components. You will see there are a lot of cores. And all I want to draw your attention is that many of these cores have services. And these different services, they help us collect cutting-edge research data across all aspects of Alzheimer's. And they also provide clinical services where they diagnose and follow up patients with Alzheimer's disease. So this is a large structure. And I want to also draw your attention to the brain donor program. People who are enrolled in the ADRC donate their brain, and there are about 300 plus donated brains in the brain bank at the ADRC, and we're doing all kinds of neuropathological research on that tissue. So these are the two studies. The ADRC has a cohort which includes over 1,100 people, and the RAP has over 2,000 people enrolled. Between the two studies, we have over 3,100 people who have been followed for up to 22 years. Think about the amount of data and the biospecimens and the donated brains we have collected from these two studies alone. And Dr. Carlson will talk a bit more about the kind of data that is collected, but all data collection between the two cohorts is harmonized. So we have the same protocol, and we can actually integrate all that data for very sophisticated analyses. Here are some distinctive research trends of the ADRC in the Alzheimer's program. The most important is the imaging and the fluid biomarkers of Alzheimer's disease. This place is world-renowned, and we are so glad that a lot of cutting-edge papers have come out of this program in this area. The other is we're trying to study how Alzheimer's differs across populations. What we see in non-Hispanic white population does not apply to Black population or Hispanic or Asian American. We need to really study those other populations to understand the pathobiology and other aspects of Alzheimer's disease. We have two of the largest cohorts of African American and American Indian participants here. Between RAP and the ADRC, we have over 800 African Americans who are enrolled in our studies and over 100 American Indians. So that population is pivotal for us. The other is community engaged behavior in every community in Wisconsin, underserved, underrepresented groups, and that is an important activity of the center, and also our focus on social biological basis of Alzheimer's. And our ADRC was the first one to establish dementia care research. We also wanted to research how do we care for people who are suffering from the devastations of Alzheimer's disease. All right. Slide, you're going to hear a lot about biomarkers. This is just a very basic slide of the blood biomarker, and we have biomarkers to detect amyloid pathology, biomarkers to detect tau pathology, to detect inflammation in the brain, and to detect the axonal neuronal death. These biomarkers can all be measured in blood. We do this all the time here in the ADRC, and there are many more biomarkers that we assay here. All right, here's the ADRC lab equipment. You could tour it. You learn a lot about it, state-of-the-art technology and equipment, and we can do all kinds of assays. So there is a machine called Alamar in our lab. You will see it here. This platform now, from a venous sample, analyzed 220 proteins in a small blood sample. And these proteins can tell you in a person what kind of molecular mechanisms are active in regard to the neuronal death. Hope this is helpful. Is this useful? Yes? Okay. So here we talk about precision medicine. Okay? And that's how precision treatment will come out. That you will know what mechanisms are active. Okay, all right. All right. And I'm in the second class. And here's another. Okay, now we can, these are the 220 analytes. In addition to detecting all the mechanisms, these analytes can tell you what other co-occurring diseases exist in that person. So once again, venous sample, drop of blood also we can go. Okay, on the last slide. Some of the accomplishments in the last year. Very lucky to have some major funding from the NI for the program. We are very productive, over 1,200 papers over the last 12 years. And as I said, we maintain the largest cohort of African American Indian population. The WLS study, funded by Dr. Karaker, it includes over 10 populations. Okay, do I end here?
We're just laughing. She's for some funding.
Because what they're talking about is we did for 60 years, and you know a lot about it, but you're going to learn a lot about during this presentation. This is just to share with you, we got another center grant from NIH called Nathan Shaw. It is aging biology research, works closely with the ADRC and WLS, and we have a very integrated aging program. And last slide, these are some new priorities of the program, and you will hear about these things. And again, finally, it'll take a village to win over a deep time. Thank you for your time. Sorry I went over.